right? There's coal in them there hills, and we're filling in the valleys, right? I saw, do you guys know this? They're getting coal in West Virginia. It's called mountaintop removal. Because who needs a mountain, right? Basically take giant machines, carve off the top of the mountain, throw all that stuff in the valley, and then get all the coal out of there, right? And then they go to the next mountain because it's all sedimentary rock with coal seams in it that's all been folded up like this, right? I saw a bumper sticker that said, "Almost level, West Virginia." It's like kind of funny. Is that funny? Do we know the John Denver song? Yeah, Almost Heaven, West Virginia. We don't know this. This is, okay, but anyway, it's a song. John Denver was a musician, and that bumper sticker's funny. Okay, so anyway, this is what you need to know, is that the average power, and this is just the power, the average power in this case is actually 1/2 of I, the peak power, squared, right? The average power is actually 1/2 of what the peak power is. And the reason that it's 1/2 is that we could take, just like those coal mining companies, and take the little tops off and fill those in, and that would represent the power continually, if it were applied continually. Does that make sense? Right? So what we do is we pretend, if we average the current, we make an average such that when we square it, we get 1/2, right? So the relationship is just simply this, okay, is that I RMS, okay, is equal to the peak divided by the square root of 2. And here's how it works, right? If I plug that into I squared R, right? If I plug this into I squared R, I go P is I squared R, right? And that equals I naught over the square root of 2. I'm just substituting, right? Okay? Times R. If I substitute the RMS, which is this, in there, and I square it, what do I get? Do I get this? Do I get that? Yeah, so we know that's true. Okay? So that's why when we do these things, and remember that the formula for voltage is the same thing, right? Power is V squared over R, right? And so the other relationship is that the voltage, the RMS voltage, is equal to the peak voltage divided by the square root of 2. Okay? So what was our peak voltage on our oscilloscope? What did we say it was? I wrote it down. It was 170, wasn't it? So tell me, what is our RMS voltage? Take 120, divide by the square root of 2. What is it? Oh, smart Alec. Yeah, 170. What is that? It's about 120, isn't it? Yeah, so 120 volts, what they tell you the voltage is RMS. Here's a general rule that I'll go by, is that if somebody refers to an AC voltage, they're talking about RMS voltage. If you take a voltmeter and turn it up to AC voltage and you plug it in, it's telling you the RMS voltage. RMS goes without saying. When we talk about an AC voltage, that's what we mean. If we mean peak, we'll say peak. Okay? But otherwise, it's like, what's that from Animal House? Pledge pin! Right? He's like spitting in the guy's face. So if we mean peak, we'll say peak, otherwise it's RMS. Okay? There are fancy voltmeters, by the way. You can buy these digital voltmeters and you can turn it to peak voltage and it'll tell you what the peak is. That's kind of fancy, right? But generally it's RMS. All voltage ratings, all references to voltage, they really are talking about RMS. Okay? So, da-da-da. Yay. We've got that. Peak, they'll mean peak. Yay. Okay. And I think our formulas that we have are this, and then I think we also have that power equals 1/2 I naught V naught. I think these are our formulas. Right? And then the other happy formulas are that power is IV, power is I squared R, power is V squared divided by R. Right? So let me do an example and then I'll have you guys Okay, so here's this example. A 13.5 ohm resistor has a peak voltage of 207.0 volts across it. What is the RMS voltage? What is the peak and RMS current through it, and the power and peak power that it dissipates? The power and the peak power. What is the power and the peak power? Sorry. Okay, so I know that my resistance, and there's, by the way, there's no RMS resistance. There's just resistance. So rest assured that that part of your life stays normal. Resistance is 13.50 ohms. Okay, the peak voltage is 207.0 volts, and so our RMS, I guess that's the first question, right? What is the RMS voltage? VRMS is less than that, isn't it? Less than that? I never use the formula. I just know it's less than that. I know it's square root of 2. Square root of 2 is bigger than 1, so we're going to divide by the square root of 2. 207 over the square root of 2. So 207 divided by a square root of 2. 146.371, is that what it is? 146.371, and I'm going to store that in A, because that's the first question, right? Okay, so that's the first one. What is the RMS voltage? We got that. What is the peak and RMS current through it? Well, this is easy. The peak current, Ohm's law works with wires. As long as it's not like a capacitor or some fancy thing like an inductor, Ohm's law just works. So if it's a piece of wire, right, then Ohm's law just says that voltage, the current is V over R. So if I want the peak current, I use the peak voltage to calculate it, right? So the peak, it's just 207 divided by 13.50. There's no tricks there, although you could psych yourself out. 207. So peak voltage divided by resistance gives us peak current, right? Okay, so that's 15.3 repeating. I'm going to call that B. Store that in B. Okay. Then it says, what is the RMS current? Two things I could do. Can I take that and divide by the square root of 2? Right? I can use this formula here, just divide peak current by square root of 2. Right? I can also do this. I RMS equals VRMS over the resistance, right? So I'm going to use this guy here, 146.371, right, divided by 13.50. And I don't know why I did that as opposed to just dividing the answer I had in my calculator by that. Maybe I felt there was more to life, right? Okay, divided by 13.50. So 10.84. I'm going to store that in C. Whoops. There we go. I'm just storing these because I think I might use them later. So now we've gone, what is the peak and RMS current through it, and the power and the peak power. Okay, the simplest way to find the power and the peak power, right? Power means what is it on the average. Peak power means what is the peak, right? The simplest way is to just use the peak voltage and find the peak power, right? Okay, so peak power is just going to be, I'm going to use V squared over R, only I'm going to use the peak voltage, right? So I'm going to go 207 squared divided by 13.50. 207 squared. And this is 3174 watts. And then what is the, if that's the peak power, what's the average power? Ooh, are they in trouble? Yeah, they are. How do we find the average power then? Is it just half of that? I think so, right? Okay, so that divided by 2. So the average power is 1587 watts, right? And what I used was 1/2 of the peak power, right? Okay. Now the other way I could have found the peak power is, couldn't I have done the peak current times the peak voltage? Yeah? Wouldn't that work? So I could also go 207, this is a way to check my answer, right? Times the peak when I put in B, so I'll go alpha B. And sure enough, I can also go peak power is peak current times peak voltage, which is in this case 15.3 repeating, right, times 207. That also equals 3174. And then the real power is just, can I just do IRMS, VRMS?